Okay, we're looking at something that's in standard form, and we are putting it into factored form. All right, and so far I have got it, the 3 factored out, and I know it's got to be 2x and x to make my 2x squared. These two numbers are always then just torture. You've got to find a combination that will both make it negative 3, and when I FOIL it out, first, outside, inside, last, it needs to make this middle term come out. That's the key. It's all about the middle term. All right, so what combination makes a negative 3? Well, I'm going to try a negative 3 and a positive 1. Some of you might be like, oh, that's not it, Mr. Server. Well, if I got lucky, cool. If I didn't get lucky, I have rules for figuring out what to do. In fact, I got too lucky. Now I won't even be able to show me my rules. I'm going to go like this. A plus there and a minus there. Okay, and I know I just messed it up. But let me show you how to think this through. The first already is good. That part made 2x squared. The last is still good. It's got a positive 3 and a negative 1, so it'll make negative 3. But it's the outside and the inside is where it's all going to happen. The outside here and the inside here would make positive 3x and negative 2x, and that would make positive x. Oh, that's the exact opposite of what I wanted. So then I'd switch my signs around. This plus has to be a minus. This minus has to be a plus. All right, if I had not just been opposite of what I wanted, if I was way off, I switch my numbers around. All right, now I'm going to clean this up. It's 3, 2x minus 3, x plus 1 equals 0. What does that mean in the context of a graph? Do you get this thing as a parabola? How do I know it's a parabola? Because it's got an x squared in it. That's the biggest power, so it's got to be a parabola. Do you get there's no negative in the front? Therefore, it's a normal parabola, not upside down. It's like a U-shaped parabola. So it's kind of like that. But where exactly does it touch? These guys tell me where it touches. X plus 1 equals 0. X equals negative 1. Negative 1. That means there's a spot where it touches at x is negative 1. So there. Now I'm making it touch where x is negative 1. And this other spot, 2x minus 3 equals 0, 2x equals 3, x equals 3 halves, or 1 1/2. So if I want to make this, maybe budget it over a little bit like this. There we go. Now we got it touching at negative 1 and positive 1 1/2. There. That's what my parabola looks like. All right. Now, how do you find the slope of a parabola? That's a little weird. So you guys already know how to find slope of a straight line. It's just rise over run, and give you 2 points and you're off and running. No big deal. But this, it's as simple as this. You can only find the average slope to start with. Then you can find what's called the instantaneous slope. But we're not going to go all the way into that. That's what you do in calculus. If I wanted to find the average slope from here to here, I made it so that it would be not exactly level. It's slightly rising, but just a little tiny bit. Do you get then? I'm finding the slope from like negative 1 to positive 2. I'm finding a slope over that interval. I'm finding a slope from negative 1, which is like right here, to positive 2, which is like right here. Do you get that that looks a lot like the point negative 1 comma 2, but it is not. That's an interval. That's the interval from here to here. What's the average slope? Well, it's pretty close to just flat, which would mean it doesn't have any slope over that time. That's all you can do is average it. Okay, it's sort of like my speed. Do you get, if I were to run from here to the door, I would start out going kind of slow, and then I would end up going much faster. Do you get all I can do if I'm going to not do super complicated equations is find my average speed? Get what I'm saying? So you're just finding the average slope. So let's say you have a curve like this, and I say, what's its slope? You would have to say, well, over what interval? If I say, oh, from 0 to 2. Let's say here's 0 and here's 2. I can find the average slope in there by just taking that dot and that dot and finding their slope. Do you get the slope looks like it's pretty much 0? From 0 to 2. From 0, which is 0, 0 here, to 2. The slope doesn't really look like it's very steep. It might be slightly negative. It might be slightly going down as we go from left to right. There is a formula for finding out exactly what that slope is, and that's the only complicated thing today. And I'll show you that slope formula in a minute. So for right now, though, let's go through some things that I hope are like easy peasy for you about slope. Do you get these guys' slopes are different? So what does that mean about those lines? They are not what? They are not parallel. If their slopes are different, that means one might be like this and one might be like this. They are not parallel, and therefore they will cross. Of course, the most important spot always is where do they cross. All right. How about this? What if I made these equal? Now what can we say about those two lines? They are parallel. Okay. And do you remember what you're supposed to do to make this not parallel, but that other thing? What's it called? Perpendicular. Do you remember what you're supposed to do with the slope? What do you think the answer is in this case? 1/3 is close, but it's not right. It combines those two words that I always was messing up last unit, inverse and reciprocal. You have to do the inverse and reciprocal. That's how you get two lines that are perpendicular. All right, so can you imagine a person might say, I got 2 points. Can you find the line, the slope of the line that goes between 3,6 and 9,12? I hope you can find that slope because you're way behind if you don't know how to do that. Now, what if you had to find a line that's parallel to these 2 points? A line that's parallel to the line that could go through these 2 points. Well, then you're still just looking for the slope between those 2 lines. What if I said I wanted to go through this point here and be perpendicular to this line here? Do you get how that would look? I wanted it to be perpendicular to the red line, but I wanted it to go through the blue point. Well, let's say that blue point is at 3, how high is that one? 12. So let's make that at 3,11 right there, or 3,10. If that point is 3,10, I'd like you to write me the equation of a line that goes through the blue point and is perpendicular to, remember that's inverse reciprocals, the red line. I'll pause for a minute while you give that one a try. Okay, if you didn't remember this one, I want to give it to you so you can use it. Y minus y sub 1 equals m times x minus x sub 1. That is called what? Come on, say it. Point slope. Slope, point, slope, either one. That's the point slope equation is the way I would say it. Because it's got a place for a point, and it's got a place for the slope. Point slope. Well, I got a point. So basically, I just need a slope. So then I don't just find the slope of this guy. I find the slope of this guy and then do inverse reciprocals on it, right? Okay, so the slope of that guy will be 12 minus the 6 over 9 minus the 3, which would be 12 minus 6 is 6, and 9 minus 3 is 6. 6 over 6 is 1. Ooh. So then I don't use a slope of 1 for this new blue line. I use a slope of -1. And now I've got my slope, which is -1, goes right here. And I got a point, which is 3, 10. 3, 10, goes like that. Raise your hand if you had that one right. Okay, good. So now, I think you're ready for that that slope of a curving line thing. Do you get, it totally depends on where I pick I could have, do you see a spot on this that has a really steep positive slope? Do you see a spot that at least has a negative slope? Okay, so if I were to say, let's put some numbers on here. Would you agree that between 0, which is right here, between 0 and 1, you would have a positive slope? Because it'd be going from here to here. And if I draw a line through that, you can see it's got a positive slope. If I make it from 2 to 5, would it have a positive or negative slope? There's 2 to 5. There's 5. Pretty steep positive slope. Can you make it more steep? Hey, you'd say the interval from what to what? Interval between 4 and 5, for example, would be pretty steep. All right, here is the official formula for figuring out the average slope. I don't know what just happened. Hold on. I was trying to drag over this. Okay. F of B minus F of A over B minus A. Why is it slope? It's still the change in F of X. It's basically the change in Y. Put the phone away. Over the change in X. Change in Y over the change in X. Doesn't that sound like rise over run? It's basically just rise over run again. I know this makes it look really complicated, but A comma F of A is just what you do when you put in an A, you get F of A out. It's just the result. All right, and now its secant line, it's just a line that goes through those 2 points. Fancy name for it. When I got to this problem, I freaked out a little bit because I'm like, what are they giving me a point there? They are not giving you a point there. What are they doing there? The interval. It's the interval between 1 and 2. So when they say this, be careful. They're not giving you a point. They're giving you an interval over which you've got to find the slope. So now if this had a big X and Y axis on it, it would be something like this. And they're saying, I want you to find the interval between 1 and 2. Let's say that's 1 and that's 2. They want to find the average slope in there. All right, so now we can just use this little formula. And hint, they're saying between 1 and 2. That's saying between A and B. By giving you 1 and 2, they were giving you A and B. Would you please then use that little formula right here and find F of B minus F of A over B minus A. It's definitely more complicated slope than you did last year. So it makes it pre-calc. Pause for a second while I give that a try. Okay, we should start again. So if I'm going to put in F of B is the first thing I'm supposed to figure out. Okay, this is B. So basically it's F of 2. So if I'm going to do F of 2, I'm going to stick in the 2 right there. Should have got 3 times 2 to the 4th plus 2. 2 to the 4th is 16. 16 times 3, oof, that's getting big. 16 times 3, let's see, that's 30, and then 6 and 3 is 18. It's 48, plus 2 is 50. Cool. I got 50 for this part. Can anybody verify the 50? All right, good. Then I'm going to put in F of A. That means put A into this function. Thankfully, that's a nice, easy one. Because 1 to the 4th is just 1. 1 times 3 is 3. 3 plus 2 is 5. So 50 minus 5 over, and this bottom part, super easy. B minus A, 2 minus 1. 2 minus 1 is 1, of course. So then this final answer is 45. What did we just figure out? We figured out the slope of that curvy line. Is that curvy line this curvy line? No, it's not. That's just an example because that says f of a and f of x, and that's not our function. Our function is this function. Did you know what that function looks like? Do you have any clue? X to the 4th is kind of like an x squared, except it's way steeper. So it's like, woo, super steep. And then the plus 2, what does that do? What's plus 2 do? Moves it up a couple. There. That's what that function looks like. Now, does it make sense that between 1 and 2, your slope would be super steep? Yeah. Because between 1, let's say 1 starts here, and 2 is like pretty much straight above it, yeah, you're going to have a super steep slope. Could we find a spot on this function where the slope would be almost 0? Yeah, if I said like between here and here, that's got it toned it down a lot. Or if I got really strategic and said between exactly there and exactly there, I could make the slope be 0 if I wanted to. Is the slope of a 0 a thing? Yes, it is a thing. Is slope of infinity a thing? Nope, you can't really do a slope of infinity, but you can definitely do a slope of 0. That's like flat ground. Makes sense. Okay, that's how to find average slope. Once again, this is not a point. This is an interval. X is 1, from x is 1 to x is 2. Like on a graph, it's saying, I want you to find the slope between here and here. And then you can plug it into the equation. Nice thing, you don't have to even look at the function. You don't have to know the graph of these functions. You can just obey this, and you got it. Okay, back to the nice, easy world again. If the slope on this guy is 2/3, well, this, first of all, the line you see there is not a slope of 2/3. It doesn't rise 2 and run 3. That would be, this is pretty steep. In fact, what is this slope? Well, I can just look at it quick and go, it rises 2 and it runs 1. That's a slope of 2, right? Okay, so if this guy's slope right here is 2, if I had a slope of 2/3, what would be something parallel to that slope? Don't overthink this. It's 2/3. And then, what would be something perpendicular to it? -3/2. Very good. Okay. All right. Now, they're making this more complicated by adding in word problems, which honestly it's okay in this lesson because, you know, we've done slope for a long time. The only thing complicated at all about these is this kind, and we're going to give you the formula. So you just have to stick, and if you know these are A and B, you just have to stick to the numbers in the formula, which makes it pretty easy. So it's okay to have you think through these things. Now, in past problems, they did have the revenue mixed up with the profit, and like the numbers were goofed up on some of these. So let's just make sure that this isn't goofed up. If we do R of X, that's revenue. Do you know what revenue in a business means? I get a lot of you probably don't. What do you think? It's not the same as profit. Yes? Very good. It's the revenue is how much money you brought in. Like at a grocery store, do you get that they bring in a ton of money, but they also have to pay them a lot of money for all the food that they get, right? So they actually don't have much markup there. They might bring in, Cub might bring in $100,000 in sales in one day, but the food they actually sold might have been cost them $90,000. So they might have made 10 grand, from which they have to pay all their employees, and you know what I mean? So they have a small profit margin. Apple, on the other hand, has one of the highest profit margins that exists because they spend a lot of money on their research and development. Okay, but if they actually, just the cost of making a phone compared to how much they get for the phone, they have a big profit margin there. So out of their $800, they might have 300 of it is pure profit. And I'm not saying that's the exact number, but it's a lot. They have a highly profitable business. Okay, some things have to work on high revenue, others work on high Like they don't bring in that much for each item, but they have high profit value, profit margin. At the store, things that have high profit margin are like cords. At Best Buy, think about it. If they sell you a cord for $15, they might have paid $1 for the cord, and they sold it to you for $15. Okay, they make a ton of money on a cord. But on TVs, their profit margin is very low. They sold it to you for $800. They probably paid $700 for it, maybe $750. So they might only make $50 on a TV, but on a cord, they might make 15 on one cord that they sell you. So they really work hard to try to sell you the things with higher profit margins. All right. Now, if we were going to sketch the graph of the following function. All right, this I hope you would get is just a domain and a range, and they're limiting you. We don't need to worry about this. This is a challenge question. All right, and we are going to have a few questions. Let me see if I can find them. Starts here. Do you remember the average rate of change formula? He's got a short-term memory. I'm going to write it down on the screen for everybody to use. Started with f of b minus f of a divided by not just b minus a. Good. There's your little formula. Remember, this is not a point. This is an interval. That's the interval from -1 to 2. If I were to sketch this for you, here's what x to the third looks like. And if I do this from -1 to 2, do you get that I'm basically saying from this point to this point? Do you get it's going to have a positive slope? If it didn't have a positive slope, I would think, ooh, I may have done this wrong. All right. Do you remember the butterfly function? Do you remember that it kind of looks like this? If I'm going to do the interval from 1 to 5, that's from like here to here. Do you get it's going to be a negative slope in that little zone? If I'm going to go from 1 to 5, here's 1, here's 5. If I'm going to check in there, I would say, okay, so here's a point here, point here. It's got a negative slope. Not a steep negative, but it's actually a pretty gentle negative slope. All right. In this zone here, it's still going to be the same exact process, same exact formula. Don't let this freak you out that the function just has a square root in it. You just do f of 0 and f of 16. I think you actually start with f of 16. All right. And then we have a word problem. And this one isn't revenue and profit and stuff. This is Fahrenheit, temperature in Fahrenheit, blank hours after 6 a.m. Basically, temperature, I can tell from this graph, they're saying temperature is going to fall. At least it's going to be an upside down kind of a thing. Do you get that that's temperature goes up until it hits midday, and then temperature goes down again? You know what I'm saying? Okay, so then they're saying between 0 and 12, that's between, these are the hours after 6 a.m. So that basically means starting 0 hours after 6 a.m. and going to 12 hours after 6 a.m. That's basically during the daytime. So T of 4, what is it? Is it the temperature? No, T is not temperature here. The little t, sorry, actually, big T is the temperature. The big T is the temperature at little t 4 hours after 6 a.m. It's not 4 p.m. It's 4 hours after 6 a.m. So this right here is asking for the temperature 4 hours after 6 a.m., which would make it at 10 a.m. Then you can use the little average rate of change formula for this. It'll work. It's just got a formula just like the other ones. You're going to stick in f of b minus f of a, etc. All right, so this just actually makes you use a real world situation for your little temperature formula or change formula. Okay, that's it. That's all I got to teach you for today. Yay. Let me look and see if there's how much more there is on homework. Okay, so this is finding, yes, we do these because this is actually more common on the tests and stuff than the other kind. And I don't think we need to do all of these though. Holy cow, there's plenty in there. So we're going to go back to, all right, I'd like you to do, and this is find the line parallel to this line which passes through the given point. All right, so it's got to go through this point and be parallel to that. It's pretty easy. Let's just do one of these. Let's do 61. Just that one. Skip all the others on that page. And then over here, it's find the line perpendicular to it, which passes through the given point. I did one of those with you. Find what the slope of this is. It has to go through that point and be perpendicular to this. So its slope won't be 1/3. You'll use a slope of negative reciprocal. All right, let's do number 66. Only number 66 off that whole page. All right, and I think number 8 is worthy of your time. That's actually I could see that being a stretch kind of question on a test. Not an R4, but like a hard R3. If you know these two are perpendicular, and what do you know about them? That their whats are what? Their slopes are inverse reciprocals, okay? So then you better solve them for y so you can see what the slopes are. All right, it's only a hint I want to give you on that. So yes, I do want you to do number 8. And that's, I think, let me make sure it's a reasonable size. 1. That one's super quick if you know what you're doing. 2, 3. Again, the only thing we're doing there is 61. So 3 questions so far. That one's a good word problem. Got to do that one. More like the test than anything else. And then on this page, I can have you skip one more. You could skip this one. Skip 49. Okay, that cuts it down to very reasonably sized. Way less than 10 questions. And now, that's all I got for you for today.